We can explain it by taking example of sodium chloride, that means table salt. As we know, sodium atomic number 11 has 10 electrons in core, that is 1s2, 2s2, 2p6. This electronic configuration is equal to neon, and 3s1 is in valence shell. That means 3s1 electron is removable, ionized. Sodium loses to form sodium cation. However, chlorine, which has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5, has valence electrons 7. 2 of them in S subcell and 5 of them are in P subcell. That means 3s2, 3p5 are the electrons present in valence shell. So chlorine requires 1 electron because chlorine is non-metal and it has high electronegativity. So it requires 1 electron to get octet, most stable configuration. And by gaining 1 electron, chlorine becomes chloride anion, Cl minus. So this I explained how NaCl is formed. Here in figure it is given when sodium has atom loses 1 electron to form sodium cation, how the electronic configuration changes. Similarly, how chlorine atom gains 1 electron and becomes anion. In this way, sodium cation and chlorine anion, two ions of opposite charge, attract one another by very strong electrostatic force of attraction. This electrostatic force of attraction between cation and anion is known as ionic bond. Here I am explaining one crystal, sodium chloride crystal. Sodium chloride crystal, that means when we are touching the table salt, you will feel that it is crystal structure. In each crystal, 8 sodium cation are surrounded around 1 chloride anion, and vice versa. Each chloride anion is surrounded by 8 sodium cation, or each sodium cation is surrounded by 8 chlorine atom, as the structure says. Here I have given the structure, and in this structure we can see how in this structure we can see how in this structure we can see how the very strong electrostatic force of attraction is in the crystal of sodium chloride among cation and anion. Obviously, the force of attraction, that means the ionic bond, is very strong in all ionic compounds. And ionic compound, due to this strong force of attraction, exist in solid state at room temperature, as you can see in table salt, sodium chloride. Similarly, quicklime, calcium oxide, calcium carbonate, and potassium chloride, potassium fluoride, all these ionic compounds exist in solid state because of very strong ionic bond, very strong electrostatic force of attraction. If we discuss the properties of ionic compound, very first property, the ionic compounds have very high melting point. Very high melting point. Why ionic compounds have high melting point? Suppose NaCl has very high melting point, that is 815 degrees Celsius. Why it is so high? Because very strong electrostatic force of attraction among the large number of cation and large number of anion in the crystal keep together ions, anions and cation. And to break this force of attraction, that means to break the electrostatic force of attraction, we need large quantity of energy, which can be achieved by heating up to high temperature. And that's why the melting point of ionic compounds are generally very high. Second property, ionic compounds in solid state are not good conductor, but in liquid state, when it is dissolved in water, the ions get free from one another. Ions are mobile in aqueous solution. When NaCl is dissolved in water, the crystal broken down into ions, the cations Na plus and Cl minus anion get free from one another, and these cations and anions in aqueous solution are movable. That's why when electric voltage is created in aqueous solution of NaCl, current passes through aqueous solution of NaCl. This is because the cations and anions are mobile, and these ions carry charge from one pole to another pole. That's why the aqueous solution and even the liquid state of ionic compound, ions are free, and these ions are charge carrier from one pole to another pole. That's why liquid state of ionic compound and aqueous solution of ionic compound carry charge. They are good conductor of electricity. Let me explain by giving figure. Now I'm trying to explain by making some so ions in solid state ions are closely packed. These ions are not free, are not free. Therefore, the solid ionic compound is not good conductor. It means to be conductor in a substance there should be either free electron or ions who are mobile in that particular sample. If electrons are mobile, if ions are mobile in the given state, then that state of substance will be conductor. Without mobile charge, the conductivity is not possible. So ions are closely packed, they are not mobile, that's why it is not good conductor. Now the second question is, why ionic compound in its aqueous solution or in liquid state is good conductor of electricity. The answer is in aqueous solution or in liquid state ions means cation and anion both, and anion are free and mobile. When the aqueous solution of NaCl, suppose NaCl of aqueous solution of NaCl we are taking, then Na plus and Cl minus are free in aqueous solution, and therefore when we are giving some voltage, when voltage is applied in such solution, the solution acts as a good conductor. So the conductivity of aqueous solution or liquid state is due to free ions in that state. So in aqueous solution or in liquid state, ions are free and mobile. They conduct, they carry charge from one pole to another pole. Charge from one pole to another pole. So I think the conductivity of aqueous solution or liquid state is explained. Now let us consider the third property of ionic compound. Now the question is, why an ionic compound is soluble in water? Answer is, water is a polar molecule. Okay, that means the structure may be given like this. So H is positive charge and O is minus charge, because hydrogen has less electronegativity, oxygen has more electronegativity, and the more electronegative element pulls the shared pair electron towards itself. So the water molecule is dipolar, and whenever NaCl crystal is dropped into water, the oxygen pole of some of the H2O molecules, oxygen pole, that means negative pole, attract the cation. That means Na plus. Similarly, at the same time, H plus of other H2O molecules pull the pull the chloride anion. Here there is a mistake. Chloride is anion. So I should write minus charge over Cl minus. So this chloride anion is pulled by H plus of other H2O molecules. We may give some more H2O molecule in this way, and the electrostatic force between Na plus and Cl minus is broken down by this attraction of H2O molecules. As a result, Na plus gets separated from Cl minus and NaCl solid dissolved into water. So this is the solubility. This is the cause of solubility of an ionic solid. Thank you.